All right, this quick video is going to be about transforming quadratics, horizontal shifts, vertical shifts, stretch, compress, reflections, that kind of thing. And I'm going to start with quadratics, which will lead us into other functions, but this is sort of the most basic one. We'll be looking at the parent graph y equals x squared. The most simplified version of an equation is called the parent graph. And I've drawn a quick graph of y equals x squared. We can just do a couple quick labels there. And of course, hopefully we all know that, 0 squared is 0, 1 squared is 1, 2 squared is 4, and so on. So what if I want to look at a new equation, which is y equals x minus 2 all squared? Well, one thing I immediately notice is that if I make x equal 2, then I get an x-intercept, which means that this graph has a vertex at 2. And I notice that if I were to plot a couple points, that in fact, this graph is just the exact same graph, but shifted over by 2. So this shifted horizontally to the right by 2. Let's look at y equals x plus 2 squared. Similarly, if x is negative 2, then y is 0, which means that I'm going to have a vertex right there at negative 2. And doing some quick calculations again, what I discover is that this graph also has the exact same shape, but it is shifted left by 2. We can generalize this as y equals x minus h squared, where h is my horizontal shift. And notice that it's always going to be in the opposite direction of the sign. So in this case, I've got h equal to positive 2. In this case, I've got h equal to negative 2. And there's my horizontal shift. That's actually the most complicated transformation of quadratics, because if I take a look at vertical shift, well, if I want to shift the whole graph up by 5, for example, here's my parent graph, 4, 1. If I want to shift it up by 5, well, if I just take y equals x squared plus 5, what have I just done? I have just added 5 to every single y value. So my graph now is going to be at, well, I didn't really make it tall enough. My graph now is going to be at 5 instead of 0. It's going to be at 6 instead of 1. And it's going to be at 9 instead of 4. And similarly, oops, that was a horrible graph. Similarly, I could also add a negative number. So generalizing this one, what we get is we get y equals x squared plus k, where k is my vertical shift. I like to tell my students that H is for horizontal and K is for kangaroo, because kangaroos jump up and down. They get a kick out of that, but hey, they remember it, and that's what matters. Guys, let's talk about the last one, which is stretch or compress. Stretch is to make it go up faster. Compress is to make it go up slower. And what I notice is, once again, I've got my basic parabola here. If I wanted to go up faster, I could just multiply everything by some number greater than 1. And if I want to go up slower, I could multiply by some number between 0 and 1. All my y values get multiplied by 1/2. All my y values get multiplied by 2. And we generalize this as y equals a x squared. So let's put this all together. Parent graph, y equals x squared, and the general equation for a transformed parabola, y equals a parentheses x minus h squared plus k. This is in graphing form, where this is stretch compress, this is horizontal shift, and this is vertical shift. And then one last observation: if I take my parent parabola and shift it h to the left or right and k up or down, my vertex, which started at 0, 0, will end up at h, comma k.